Hi, good afternoon, everybody. If you could hear me and see the screen, say good afternoon, and we can jump straight into it. Just looking at the chat, waiting to see everyone who joins. Okay, just doing something weird. It's not loaded yet. I'm gonna let you know when it's loaded, and then you'll let me know how it looking. Why is it doing this? Hold on 1 minute, guys. Something glitching. Okay, I think I have it now. All right. So everybody should be seeing a blank screen right now. Confirm yes or no. Let me take a look at who's present. Just send a message out to some of my students to join, and then we're going to get started. Today's topic is trigonometry and question 9, basically. So we're going to reinforce the formulas, and then we're going to practice how to read the questions, how to understand what to do with the questions, because, yeah, this topic tend to give people a lot of problems. All right, so we're going to get straight into it. So let me see now. Let me write something. Everybody, get ready, get your pens, get your pencils, get your calculators. Make sure you're sitting up, make sure you're mentally ready to begin. Um, yeah, and once you have everything, type ready and we're gonna get started. Please message me directly on WhatsApp. All right, so first thing we're gonna do, we're gonna touch base on the circle theorems. Now, at this point, everybody should know the circle theorems, and to be honest, you should be memorizing them, right? You should know them out your head, and the reason is because whenever they ask you to find a missing angle, they always gonna ask you to state the reason. Recently, they've changed this pattern, and what they do is that they tell you the answer and they expect you to give the reason or give the rules to find the answer. So this is why when you're studying, do not put too much emphasis on doing past papers only. Make sure you know all of your rules. Make sure you know all of your formulas. Make sure that you know when to use them and how to use them, because that is honestly more important and more useful than just running through a bunch of past papers. Yes, you use past papers to practice, but you don't only focus on doing them, right? Because one past paper would never cover all the topics that you should know. So it's not a sole approach that you should literally rely on. All right, so let's get straight into it. So as you know, the first part of question 9 usually stems from circle theorem. And you should know the different parts of the circle. And I'm just going to call out a few things. And if you realize there's any of the parts that you don't know, you should know what to do, write it down. So you should know what it means to find the center. You should know what it means to locate a radius, the diameter, the circumference, the arc, a tangent, a chord, minor sector, major segment, major segment. All of these terminologies, how everybody feeling about those words? Everybody good? Everybody know those words? They know what it means. You know how to find it. You know the properties of those words. You never learned this. Oh my God. Okay, so if you didn't learn it, or if you don't know it, I could send you on my Miss View in YouTube. I have a class where I teach it from scratch. So it goes through all the rules and it focuses on this. So if that's something you would like me to send to you after, I can send it to you, okay? Because today we won't have enough time to teach everything and practice past papers, and we have to practice past papers today. All right, so there we go. No problem, Novi, no problem. All right, so let's go. The first one is called an angle in a semicircle is 90 degrees. So let's zoom in here and make sure we got it because I'm moving quickly because honestly, I really was hoping that everybody should have done this already at this point, but we do what we can, right? So if you look at this, the circle is split in two by the diameter, and an angle is formed on the diameter, and the angle touches the circumference. That angle that is at the circumference is what we call 90 degrees. And this rule is an angle in a semicircle. Why do we call it an angle in a semicircle? Because it's used or made in half of the circle, right? So an angle in a semicircle is 90 degrees. Next one we have is what I would call twin angles, because both angles start and end on the same chord. Even though the chord wasn't there, this is something that you should know, right? So we have angle A, which goes up here, and you see it ends and starts at the same place. Angle D ends and finishes at the same, starts and finishes at the same point. It means that these two angles are equal. So if this is X, this is also X. All right. So this term or this theory is angles in the same segment are equal. Next one we have here is whenever a triangle is formed in a circle with the two sides being the radius, and you should know a radius is a line that connects the center to any part of the circumference. So this is one radius, and this is another radius. And anybody know the plural word for radius? What do you call two radius? That's important to know as well. What? Excellent, radii. So anytime you have two radii, they form a triangle, and they form a specific type of triangle where both sides are equal. So we call this an isosceles triangle, an iso triangle. And something that you should know about the iso triangle, if these are the two sides, at the base of the two sides, it has equal angles as well. Okay, next one. This one is a favorite or one of the easiest ones to remember. If you look here, we got two angles. Both of them start and end at the same positions, but one goes to the circumference and one goes to the center. And this theorem is angles at the center. So the angle at the center is twice angles at the circumference. So quick question. If here is 20 degrees, what would up here be? Quick maths. And I need everybody to be posting your answer. I need everybody engaging, because that's the reason I ask. Everybody wrong. That means you're not listening. That means you're not focusing as well. You're not paying attention. And even if you don't remember, I'm not sure, if you look at the numbers here, which one is the double one? So that means the one in the middle is supposed to be bigger. Another thing you're not paying attention to is details. Look at the size of this angle. This angle is opened up more, which makes it bigger than the angle at the top, which makes this one smaller. So if you should have done anything, you should have known that this angle should have been what? Half of it. So the angle is 10. Everybody understand what I'm trying to show you? At this point, we can't afford to just be saying answers. Always look at the details, always confirm, because this is exactly what happens in the exam. Students leave the exam saying, yeah, I mashed up the exam, but there's a lot of mistakes. Pay attention to details. Next one, we have here something called a cyclic quadrilateral. And you should know a quadrilateral is a four-sided polygon, four sides, right? And remember, a quadrilateral is not just a square, a rectangle, a parallelogram. It's any 2D shape, enclosed shape with 4 sides. And it's called cyclic because the points of the quadrilateral touches the circumference of the circle. Anybody know the next word for point? The place where 2 lines meet. There's a formal name for this with a V. What is that name? What do you call that? Excellent, vertex. Very good. And what's the plural word for vertex? Vertices. Okay, things that we should know, right? Just like index and indices, those are the same kind of concepts. Excellent. So, what is special about this rule? The angles that are opposite each other in quadrilateral, both of them add up to 180. So, if this is A and this is B, A plus B equal 180. So, quick question. If A is 100, what is B? I'm watching the chat and I'm watching who responding and I'm watching how much people are making an effort to participate, okay? Excellent job, everybody. All right, and everybody should know how they should break this down, right? So if A is 100, this is what you do. 100 plus B equal 180. And you want B, so you transpose, you carry over 100. And everyone should remember when you carry over anything, it becomes the opposite. So B is going to be left behind, and it would become 180 degrees. Don't mind the missing degrees for now. Minus 100. So B is equal to 80. Okay, what did we learn this? We learned this in algebra. And this is something that should be represented in all of your solutions, okay? Even if you know you could work it out without a calculator, we know that working is more important than the answer. All right, moving on. This is what we call the internal and external angle. So here we have a triangle inside the circle. Everybody see that, right? And then we have a tangent, and you should know a tangent is a line that touches the outskirts or the circumference of the circle. It does not enter the circle at any point. So at this point here, everybody should notice how much angles I have here at this point here. Pick a tray. That's one person. Anybody else want to try? Talk to me. Excellent job. There are 3 angles on one side, by the way. On this side, there's 3 angles. And everybody should know that there's another angle over here. This angle on the opposite side is 180, right? Just to make sure we clear in case you try anything. Because, I know they're always trying something. But for the purpose of this topic, it's 3 angles. This would be my A, this would be my B, this would be my C. All 3 of them lie on a straight line. So all 3 of them should add up to a straight line angles add up to. Everybody should know these things. Let's go, let's go. If you didn't know it before, you should know now. All angles in a straight line add up to 180. So if I add up A plus B plus C, all 3 of them must add up to 180. And these are the things you have to have in your back pocket because they help you find missing angles, yeah? So what do we notice here? We have 2 external angles and 1 internal. What do we mean by external and internal? If we look at the triangle, who is the internal? Everybody? We got 2 external and we have 2 external and 1 internal. Who is the internal? B is the internal because B is inside the triangle, right? So that's the internal. So that means the 2 angles on the sides, so here and here, we call the external angles. Everybody with me? One is on the left-hand side and one is on the right-hand side. Now, the rule that we're going to learn now, well, not learn, you should know it, revise now, is that there's something called the internal and external angle. So this is the rule. The internal angle is equal to the external opposite, or you could say the other way around. The external angle, and what side is this external angle on? It's on the right-hand side, right? The external angle is equal to the internal opposite. So inside this triangle, we got 3, but which one is on the opposite side? This is on the left. So that's why this angle and this angle is equal. Yeah? Next one. Anytime you have 2 tangents meeting at a point, and in this case, the point is A, the 2 tangents would be of equal length. And something that you need to know too, if I was to join the 2, tangents together, it makes what type of triangle? What type of triangle is this again? Anybody? Excellent, an isotriangle. And so we have which two letters would be the equal angles in the isotriangle? So we got angle A at A, B at B, and C at C. So which of the two would be the equal angles? Excellent, excellent. The two angles at the base. So because these are the two equal sides, you look at the base of them, and those two angles are the angles that we call the twin angles, the equal angles. Last theorem is the angle that is formed between a radius, and you know this is a radius because it comes from the center to the circumference. And what do I call this line again? What do we call AB or BA? What type of line is AB or BA? Excellent, a tangent. So the angle formed between a radius and a tangent is 90 degrees. And everybody should know that this symbol is the symbol of 90 degrees. Ladies and gentlemen, if you have learned this for the first time, you will just write down this entire topic as something that you need to spend some time on your own. And this is what we call circle theorems. In order for you to answer the first set of questions in CXC, question number 9, you have to know these out your head. Okay? So what we're going to do now is we're going to move on to the next section of the question 9, which is trigonometry. Everybody should know that trigonometry means the maths of triangles, right? So I'm just going to quickly highlight some things that you should know, and then we're going to go straight into the exam. If you're ready, say ready. Please note, this is a revision class. So if you have not learned any of these topics before, you still have time to go and learn it on your own. Okay? You just pick up on what you could pick up on, understand as much as possible, and you do the extra work. Okay? You got this. Now, the first thing I need y'all to do is categorize your mind. Trigonometry deals with triangles. So you should know everything about triangles that is possible to know. When it comes to a triangle, how much size does a triangle have, everybody? 3 sides and 3 angles, right? Which means you should know all of the types of triangles, and I'm going to call them out. You should know what an equilateral triangle is. You should know what an isosceles triangle. You should know a scalene triangle. You should know a right angle triangle. These are things you should know. Okay? Then you should know all 3 angles in a triangle. So if I have this A, B, and C, all 3 angles in a triangle should add up to 180 degrees. Yes, excellent. And there's a word to describe when something add up to 180 degrees. It starts with a S. What's that word? Supplementary. If you heard of this word before, say yes, please. If you know what supplementary meant before today, everybody should know this at least. Excellent. All right. So this topic is broken down into 2. So anytime you see a question, the first question you have to ask is, what type of triangle is this? Based on the type of triangle, you would know which formulas would apply. Lucky for us, most of the formulas that we need for trigonometry is on your formula sheet. So you don't have to try memorize these things, but you should still, if you know them out your head, it empowers you to move a lot faster. So you don't have to be flipping back every minute. You can flip back to back check, but you don't have to rely on it too heavy, yeah? So the first type of triangle, which is honestly one of the most important triangles in mathematics, is the big dog, the right angle triangle. And there are some properties of the right angle triangle that you need to know. That there are 3 sides. Let's pretend this look good, right? The 3 sides and the 90 degrees will go here. Every shape has a name. How do we name shapes? We name them by the letters that are given to each point. So for example, angle 90, the 90-degree angle is located at what position? What is the name of the 90-degree angle here? It's called angle C. That's one way to write it. Another way to write the same angle is angle ACB, where you follow the lines that the angles are formed by. So look at it, ACB. Another name for it is going backwards, which would be what? BCA. If you got it, say got it. You have to know that because if they give it to you, you have to know which angle they're talking about. And this is literally the whole question. This is the whole of question 9. You have to know which angle they're talking about when they name it, okay? All right, so let's jump into this. When it comes to the right angle triangle, there are only 2 main rules. The first rule is called the Pythagoras theorem. And this is how it's going to look in the exam on the formula sheet. C squared is equal to A squared plus B squared. You need to know which side is which. So everybody watching, everybody locked in. Let me just make sure. Because they're kind of moving fast, but it's because I really expect everybody to know this. And if you don't know this, it's something that you should. I just want to introduce it quickly so you know what's supposed to be happening. Yeah? Okay. So before I get into this formula, you should know how to label sides. Angles use capital letters and sides use common letters. And the name of a side is based on the angle it is opposite of. So for example, what do I mean opposite? C is facing this line here. Do you agree? Let me use green. C is facing this line here. So if this is capital angle C, this would be what? Side C. What would I name over here then, everybody? What part the arrow is that my hand's shaking by? What side is this? Excellent. Very good. And down here would be called what? A. Small a. Remember, small a. And let me explain this. It is very important to know to not mix up your capital letters and your common letters, okay? Don't forget, capital letters are for angles, common letters are for sides. Now, before we even continue, one of these sides have a name that don't ever change. And that's the longest side of the right angle triangle. And it is the side that is always opposite of the 90-degree. We call this the hypotenuse. Most people say but hypotenuse. Okay, thank you for letting me know, Arabo. I got you. Now, if we notice here, who is the longest side always? C, right? So what they're saying is that Pythagoras theorem is used when you have 2 sides and one is missing. This is the formula that you're going to get on the formula sheet. But do you want C squared or you want C? Talk to me. If we want C, how do we get C? We use algebra and we square root both sides. If I square root both sides, what's going to happen? The square from off the C going to go, and a square root over the other side is going to be left back. Okay? Because remember, if you square root both sides, a square root will cancel out a square. If you got it, say got it. Similarly, suppose I want to find a short side. You have to use algebra again. What do I mean by use algebra again? So let me go. C squared is equal to A squared plus B squared. So if C is the longest side, that means A and B are the 2 shorter sides. So suppose I want to find A. In general, how do we find A? We should learn that we always do what? We transpose. If I want A by myself, I need to get rid of plus B squared. How do we get rid of plus B squared? We just simply carry it over. We transpose. When we carry it over, plus B squared would become what? Minus B squared. So let's just switch it up so that A squared in front. So A squared is going to equal to C squared minus B squared. Again, do we want A squared? No, we want side A. So what do? We square root on both sides. So please note, when the formula is on the formula sheet, you should know that you have to square root to find the sides. So once we square root, this cancel, leaving us with A. And so we have our formula C squared minus B squared. So let's look at the 2 formulas that we have. When you're trying to find the long side, what do? You add in. When you're trying to find a shorter side, what are you doing? Subtracting. If you got it, say got it. So that means that the first rule that should pop in your head is the Pythagoras theorem. And when do we use the Pythagoras theorem? If we have a right angle triangle and we have two sides and one side missing and they want us to find one side. Do you realize this has nothing to do with angles? This rule has nothing to do with angles. Even if you have a triangle that looks like this, let's do an example because students just get confused all the time. Let's say you have this, and even though they give you this 20 degrees and they give you 15 centimeters and 25 centimeters, and they say find P. Even though there's an angle in here, do I need to use this degree? Do I need to use this angle? No, because one, this is a right angle triangle, and you have two out of three sides. So that means what rule do we use to find P? We use Pythagoras theorem. If it's a long side, you're using the addition version. If it's a short side, you're using the subtraction version. So that's the first rule we need to lock down. If you got locked, say locked. If you don't have it locked, you know what you need to do. Write down the topic that you don't know. All right, we're moving along swiftly. So the second rule now that you could use for right angle triangles is called the trig ratios. Now, I'm not going to spend too long on this because everybody should have an idea. Well, you know what? Let me ask first. See? Let me ask. Trig ratios. So trig ratios, again, is when you have a right angle triangle, just like before. But now, let me just highlight this. Pythagoras is sides only. You only use Pythagoras if you're looking for a side and you're given sides. Trig ratios, you use sides and angles. So you can't use trig ratios unless you're interacting or changing or converting or finding something in a right angle triangle with both elements. So we got 90 degrees. Now this is the tricky part. Trig ratios deals with a relationship between three sides. That's why they call it a ratio, right? Which side don't change no matter what? The height, the hypotenuse. Remember we learned that before? Or we remember about that before? The hypotenuse is always the same. The two sides that are left back is called the opposite and the adjacent. Now, those two sides are based on the location of your angle. So I'm going to try something here and let's see if you guys can figure it out. If I put 20 degrees here, right? Let's call this side A and let's call this side B. Who is the opposite? That's for everybody. Even if you ain't sure. Who is the opposite? And that's why I ask, because I want to see. That's why we're here. I'm waiting for more people to respond and not moving on until majority of the class responds. Even if you're not sure, try. Because if you make this mistake now, we need to make sure you never make it again. All right, ladies and gentlemen, I'm going to describe what the two means, and then I want you to tell me if you can stick with your answer or you're going to change your answer. Because at this moment, I'm trying to condition your mind. That's why I don't want to just tell you the answer, right? Opposite means, remember over here when we did the concept of opposites? Where did we do opposites, right? We didn't do something with opposites. When we was naming sides, yes? Look at here. So if this is A, the side that is opposite to angle A, that's why C is opposite to C, B is opposite to B, A is opposite to A. So let's go back again. So opposite means on the other side. Adjacent means next to. Adjacent means that this is the side next to the angle. So let's go again. Which one of these two is on the opposite side of the 20 degrees? No, everybody cooking on gas. You see how I didn't even have to tell you the answer? So everybody with me now? 20 is opposite to B. So that's why B is the opposite. And A is next to it. A is right beside the angle. So that's why A is called the adjacent, because adjacent means next to. If you got it, say got it. Because we're moving right along. And I'm happy that everybody shared what they thought so that we could have clarified that. Because guys, if you don't get this right, everything you do gonna be wrong. You know that? If you mislabel a side, everything you do gonna be wrong. Yeah? So try to make sure you have that clear in your mind. Okay, so let's move on. So once you're able to identify your sides, mind you, you won't ever have all three. It's usually two of them and one of them out of the two missing with an angle. Or the two sides and you're looking for the angle that is there. So what's the three trig ratios that you should know? Sorry. My voice gonna dip a lot because I'm kind of tired. So forgive me, okay? So the first rule is the sin rule or sine rule. And anybody know the sine rule? This one is opposite over hypotenuse. Then you have the cos rule, which is the adjacent over hype. And then you have the tan rule, which is the opposite over adjacent. Now, ladies and gentlemen, we don't have to stress ourselves about memorizing it. If you're aiming for a 1, you should memorize it. You should know it because that's what a grade 1 student would do. But if you feel like you don't remember, you could always flip to your formula sheet because it's going to be right on your formula sheet. You just have to remember how to use it. All right. Next thing now is if you want to find the angle given two sides. So you should know that theta is equal to sine inverse of opposites over height. Wherever this number is. Yeah? Everybody with me? And everybody look for these two things on your calculators because I'm going to give you guys some stuff to type in on your calculators before we begin the past papers. So make sure you see where your inverse buttons are. So let me make this clear. Everybody listening? You use these when they ask you to find a missing side. A lot of people don't even know the difference between the two. When you're finding a missing side, you're using the regular sine cos tan. When you're trying to find the missing angle, you end up going to use the inverse of the 3. Everybody with me? So if they say find the angle using something of a right angle triangle and you got two sides, you have to use the sine inverse. All right? So the first thing, y'all ready? If y'all got all your calculators close by in your hand, I should say, I want you to do the following. Everybody, sine 30 degrees and tell me your answer. Post your answer once you have it. Sine 30 degrees and press equal. Tell me what number you get. Let's go, guys. Let's go. What's holding up? What's the hold up? If your calculator give you a fraction, I hope you know how to change it into a decimal, right? Because usually we're trying to use a decimal. Vanny, that means your calculator need resetting. That's why I ask everybody to do it. If your calculator don't give you 0.5, your calculator need resetting. Everybody, cos 30 degrees. I say sine, no, do cos 60. Cos 60. Same thing, right? You should get 0.5 again. Tan 45. Tan 45. Excellent. Everybody should be getting 1. Excellent. Now you're gonna do the inverse for me. You're gonna click, second. Some people calculate say shift That is to access the buttons or the things above your button. Everybody should got like things above your button. So look for your sine inverse, cos inverse, tan inverse. And sine inverse should be right above sine, cos inverse, right above cos, tan inverse, right above tan. So the first one you're gonna do for me is you're gonna click sine inverse 1. Tell me what number you get. Excellent. If you get an excellent, cos inverse 0.5. Cos inverse 0.5. Excellent. Excellent. Okay, last one, tan inverse 1. Everybody realize those answers is all degrees. Everybody realize that all of those inverses gave us back the angle that affiliated with the answer. So something you need to remember, when you're signing costs and tan certain things, you're gonna get a decimal. And then when you inverse it, you're gonna get back a whole number, and the whole number is your angle. All right, so let's make sure we clear, because honestly, that's all we need to know for right angle triangles. So we know when to use Pythagoras theorem. We use Pythagoras theorem when we got 2 out of the 3 sides and you're missing one. And you use either sine, cos, or tan if you have an angle and a side and you have to find another side. Or you have 2 angles, 2 sides, sorry, and you're missing an angle. All right? And both of them are related to who? The right angle triangle. If you got it, say got it. So nobody shouldn't be thinking about nothing else if you're dealing with a right angle triangle. That's the only thing you should be stressing about in a right angle triangle. Those 2 rules. Now, these 2 rules are used in a topic called angle of elevation and depression. And I think we did this already, yeah? But again, I'm just here to revise for us to remember. So I'm just going to quickly do the 2 drawings so you could remember how it looks. If they give you a question that say a man is standing at the top of a cliff, so let's just map that out so you can know the 2 differences. A man standing on top of a cliff, and this man is looking down at the ocean, and a boat is in the ocean, and the boat is on an angle. I am a boat looking good, and my boat looking good. He is looking at a what, everybody? Is he at an angle of elevation or is he at an angle of depression? And that's important. Let's go. Let's go. More people to try. What do you think? Is he at an angle of elevation or is he at an angle of depression? Very good, guys, because he is looking down. Because he is looking down, that's an angle of depression. Everybody see that? Now look at this drawing. Can you see the right angle triangle in this picture? Do you see the actual right angle triangle in this picture? That is the most important part. Nobody care about the man and nobody care about the boat. We care about the theory that comes out to the situation. So your job is to understand that there's a right angle triangle, and because it's a right angle triangle, what rules you could use? Only 2 rules you could use. You could either use Pythagoras or you're gonna use what? Trig ratios. No, look at this. Where would I put the right angle degree? The right angle can go here because the 90 degrees is always standard, yeah? No, this is a trick. When they give you the angle of depression, the angle of depression is the angle that comes down here. So if this is 50 degrees, there's another angle that's 50 degrees. Anybody seen the alternate angles? Anybody seen the Z? So if here's 50 degrees, that means here is also 50 degrees. Everybody should know alternate angles. The Z, the angles in a Z is the same. Everybody see that? Once you get this angle here, guess what? It don't matter. No. Which line? I'm going to label the 2 lines because this is where students just lose it. Let's call this A and let's call this B and let's call this C. Which one of them out of the 3 would represent the height of the cliff? because for some reason, students just lose it. Which one of these here would represent the height of the cliff? So if they ask you, calculate the height of the cliff, you know you got to use B. Everybody with me? Suppose they ask you to find the distance between the man, the cliff and the boat. The distance between the cliff and the boat. What line is that now? This is where we have the drama, and that's where I'm glad I asked that question. Oh, you guys, this is where I'm glad I asked that question. Guys, look at the picture. This is the edge of the cliff. Where is the boat? This is the boat. The distance between the two of them is always the horizontal distance, lovies. It could never be, honestly, the only thing that they could ever ask you for this line is the line of sight. Agree or disagree? Because this is the vision that he got towards the boat. Everybody see what I'm saying now? They hardly ever ask you to find this line. And if they ask you this line, it's because they're asking you, how far is the distance from his sight of vision to the boat? Because that's the only relationship between the man and the boat, is that this is where he's looking to the boat. But it asks the distance between the boat and the cliff. This is, and this, I hope everybody with me. If you're with me, say with you before I stress myself too much. I believe I kind of make myself clear. If you're with me, let me know in the chat that you're with me. So everyone, you should know the language, yeah? The height is obviously the perpendicular distance going upward. Always, yeah, always. Distance tend to be always the horizontal distance, yeah? So it's the horizontal line. Now, I'm going to ask and give you a piece of information that you're going to answer here. If I tell you the height of the cliff is 100 meters, how will I calculate A? What topic is this? Is this Pythagoras or is this trig ratios? I ask you to find the distance between the boat and the cliff after I give you the height. What topic is this? Is this trig ratios or is this Pythagoras? So it's either you're going to type trig or pi. That's all I want. And everybody going to train here because that's what we're here for. What you should be doing right now is looking at the information you have. You should remember, Pythagoras deals with sides only. And for you to use Pythagoras, how many sides you must have? Somebody. To use Pythagoras, how much you must have? And in this case, we don't have two. So we can't use Pythagoras. Everybody see what I'm saying? So the only other option is trigs. No, let's make sure that we can use trigs. Do we have an angle? Yes. Do we have a side? Yes. And they ask us to find a next side. No, this is the trick. Which one of the trig ratios will you use? So let me go back here so you could see the options. No, you have to label your sides so that you know, okay, am I going to use sine, cos, or tan? Because that's the next thing you're required to do. Formula, substitution working. You look at the situation, you look at what you have first, then you choose your formula. So what should we do first? Label our sides, guys. So let's do that. The side that they want is A, so that means A is involved. We have 100 meters. What do we call 100 meters? What do we label 100 meters? What side is this? Excellent. No, this is up. Remember, it's either what? It's either up, it's either let me bold pi no. It's either up, it's either adjacent, or it's height. Everybody see where I'm going with this? Because that is what tells us which trig to use. So we got one side. What's the next side we need to use? In A. They ask us to find, so we need to find A. So that means A got to be involved. What is the label for A? Excellent. So now we got two sides, and everybody realize we're not using C. So if we're not using C, it's not important to us. It does not matter in this question. Do not let labels confuse you. So let me go. Which one of the ratios uses up and edge? Gav said tan. Do we agree? Excellent. No. What is the four-step thing I taught you guys? What's the four things that you always do? And once you use this, guys, you can't go wrong in the exam. Formula, substitution, working answer. I'm going to say it again. Formula, substitute, working answer. An answer with units. So if you're dealing with distance, you put back your meters, your kilometers, your whatever. If you're dealing with angles, you put your degrees. If you're dealing with money, you put your dollar sign. So there we go. 4 steps following. So we know the formula is tan theta. And you know, theta is the symbol for angles. What is the formula for that? Up over h. This is on your formula sheet, so you don't have to stress yourself. Now, second step, substitution. Tan theta. Tan is just like a function in your calculator. You know, when you tan something, you get a number, you get a decimal. So what would be theta in this example, everybody? 50, because that's the angle at hand, yeah? Remember, theta is the angle. You always tan the angle equal to up. What is up? Up is 100 meters over x. Why am I using x? X is used to represent our unknown value, which is actually what? A. If you're with me, say with you before I continue. Because we're kind of doing, what time it is? We got to move on just now, Jesus. I just wanted to make sure I clear this up before we get into the dark sides, right? Because we got to hurry up. All right, let's go. So before you continue, because we don't do the substitution step, this step is a substitution step. We just replace all of our items with their specific values, right? Now, I know, you know, we know that tan 50 is a number. Please don't ever let CXC throw you off. If even an addition question got tan something, you know, tan something is a number. You tan the number in your calculator, you write down the answer it gives you. So everybody, what does tan 50 represent? So that's we working. And I want to see what your calculator give me. So I need you to post what you get. At this stage, you try to use 3DPs. 3DPs is going to give you accuracy in your working. So your calculator give you that. So 1.192 is equal to 100 over x. Now, I teach everybody, if you've been with me from since last year, when we did our algebra, look at where x is. You have two options to transpose x. You're either going to be multiplying or you're switching. Which one is it? Everybody put in the chat which one it is. Are you going to switch or are you going to multiply to transpose x? And if you don't know, that means you got to go back to algebra. If you're weak in algebra, you better go back and study it. If you don't know what I'm talking about, go back and watch the videos from algebra that posted on my YouTube channel. I'll watch in the chat. Let's go. What is the options? Do you switch or do you multiply? Anytime the thing that you want is in the denominator. So in this example, what do we want? We want x. If x is in the denominator, the shortcut rule, because I'm not going over this again, the shortcut rule is to switch. I want to do an example like this too. Suppose I had 20 is equal to x over 4. Where is x in this example? X is in the numerator. So that means that's where we want it. We want it as the main focus of the right-hand side. So I could just get rid of divided by 4 because that's what this line means. This means divided by 4. So in this example is where I would multiply because multiplication is the opposite of division. Whatever you do on one side, you do on the other side. So this would cancel that. So x is equal to 4 times 20. So x is equal to 80. In this example, this is not the same because look at where the x is. The x is in the denominator. If I multiply by x, they're going to cancel it out from here, but bring it over on the other side, which is basically what we're doing. So the shortcut is to switch these two. So that means x is equal to 100 divided by 1.192. So calculators, everybody, x is therefore equal to What is x equal to, guys? That's one person. Is it true? No. Your answer would be rounded off based on what they ask you. Sometimes they're gonna say to the nearest meter. If you're here to the nearest meter, what does that mean? That means a whole number. So if I ask you to the nearest meter, what is the answer? So your calculator give you this, 83.89 something, 2. But to the nearest meter would therefore be what? 84 meters. Excellent job. If you got it, say got it, because we're moving right along. So that means anything with a right angle triangle, we should be able to handle. Anywhere, anytime, anywhere. Yeah. All right. Now we're moving into anytime there's a triangle that is not a right angle triangle. And this is where things get a little sticky. No, there's 2 rules that you could use. But before we get into the rules, we got to understand how to label our triangle again. So let's call this A, let's call this B, let's call this C. What would I name this line, everybody? Let me see if anything I'm learning sticking. Excellent. What would I label here? Small b, and here would be small c. Excellent. Another thing you need to note here, if A is the biggest angle, side A is the longest side. If angle C is the smallest angle, that means C is the shortest side. Why is this important? If you're working out a question, right, opposite to the smallest angle, should it ever have the biggest side? It shouldn't. That's how you know it wrong. Let me say it again. There's a relationship between the sides and the angles. So if you work out a question to find A, and you know A is the biggest side, but when you find A is the shortest side, you know that you've made a mistake because the biggest angle faces the longest side. Similarly, the smallest angle faces the smallest side. Okay? Now, let's move on. We use 2 rules to deal with non-right angle triangles, and that's the cosine rule. Let me start with the sine rule. The sine rule and the cosine rule. Where are these topics gonna get? These 2 formulas are a little long. One is A over sin A is equal to B over sin B. And you realize one is a small letter, which represents what? The side, and sin, capital letter, the angle. And the cosine rule is A square is equal to B square, sorry. B square plus C square minus 2BC cos A. Yeah. These 2 formulas are on your formula sheet, so you don't have to memorize them. What you do need to remember is when to use them. You use sin A when the angle is not between the 2 sides they give you. Angle not between, and cosine when the angle is between. How do you remember the difference? Sin is a bad thing, so sin is a no. Once it's no, you know it's not between. Everybody see that trick? So just a quick example of what we're talking about. I have this triangle. So I'm going to give you 2 sides. One side is, let's say, 20 meters. One side is 50 meters. I put the angle here, 70 degrees. Is this angle between or not between? Quickly, let's move. Excellent job, because not between would have been in between here. But because it's not between the 2, which rule you would use, the sine or the cosine? Excellent. That's all you got to know, you know. That's all you got to know. This is going to be used for 2 types of question. Bearings is the number one. You're going to use these 2 if the question is based on bearings. And you should know what bearings is. Bearings is when you use the knot line to describe the location of a specific place. So if this is my location A and this is my location B, I have to connect them to the knot line because the knot line is the from location. Let me just write from. This is the from location. So you draw your line connecting, and anybody see the angle that is formed between the 2 points, between the knot line? Everybody should know that the angle, the bearing is from here to here. How much people learned this already? If you have not, if you've learned this, yes or no? Quickly, everybody, if you remember learning this. So I could know if I could move on quickly. Mm. So let me quickly do something here. Not first thing you need to know, bearings, they use 3 digits to describe. You should know your knot lines, your lines, your cardinal points. So let's do this quick. This is your knot, right? Well, why did I write a M? This is your knot, this is your south, this is your west, and this is your east. Anybody seen the angles that exist already? What is the angle between north and east? Excellent. From here to here is 90 degrees. So the angle is 090. You write bearings using 3 digits. That's the first thing. If you write that bearings with 2 digits, you can get it wrong. You must write bearings using 3 digits. What would be the angle between north and south? 180 degrees. Why is it 180 degrees? This ain't a straight line. Everybody see that? Hello, I just asked a question to everybody in the chat. Did you see that? Hello. So obviously, you keep adding 90 degrees, right? So what would be the angle from north straight to west, going straight around? What's this angle here? 270 degrees. Excellent. And obviously, if I go all the way around back to the original point, what angle is that? So this could be 000 or it could be 360. Okay? All right. So like I said, it's important to know your angles and it's important to know your rules. So we're going to leave it here for now. We're going straight into some past paper questions. Everybody, take a deep breath. Take a deep breath. The reason I really want to put some energy here is because I feel like question 10, question 9 should be in your strong topic list. You should be feeling comfortable doing these questions, okay? You got some questions that we never know what to expect, but based on CXC patterns, question 9 is tend to be reliable. Question 9 is reliable. There are a lot of work in, yes, but if you prepare properly, that's a question that you could get as much marks as possible. So that's what we're aiming for. Okay? So we're going to start off here with this question, this exam. And I don't know why I wrote 52 here, but let's go. This is the question here. I taught you guys how to work out a circle theorem question. You do not even look at what they're asking you to find first. The first thing everybody should do is look at the picture and see how much of the diagram they could identify on their own. How much rules do you see? How much angles you could find even without looking at what they ask you for. So let's pay attention and see if we could get this done. So the first thing you're gonna do is read the instructions and make sure everything they say in the instructions is in the question. So it says H, J, K, L, and M are points on the circumference of the circle. So you look H, M, L, K. Okay, all of them are there. Good. With 0 as the center, make sure that there. MK is a diameter. So I'm looking at which rule talks about diameter already. Once you see the diameter, what should come to your head in angles in a semicircle? Hello? Where the rules gone, eh? Are they way gone? I want to move this. Where it is? Is it this? I can't see. Hold on, guys. One moment, please. Where's the table? This the table here? It gone? Anybody seen the table? I think this is it. No. Y'all know what table I'm talking about, right? Remember when we was going through the different circle theorems? That's the table I'm looking for. We ain't seen it. Well, that's okay. Hopefully y'all remember, right? So let's go back here. Everybody can see now? Guys, are you locked in still? All right, so let's go. It's 6 o'clock. Let's see how much past papers we could get done. So I'm gonna try my best to describe so that we all learn and understand. Let me see what year this was. This was January. This was the January 2025. That's the exam that just gone. So let's go. So it says LN and NQ are equal. So what type of triangle is that, everybody? Anybody see the isosceles? So let's go through the things that we see. First thing first, I see the semicircle. So let's do the semicircle first. So if this is a semicircle, what's the rule about semicircle? That means this entire angle from here to here is 90 degrees. Do you agree? Look at the triangle. Anything in a semicircle is 90 degrees. So that's the first thing I would put in. I would draw my little box. You don't wait for them to ask you what to do because you want to make sure that you put in the information yourself first. Okay? Then the next thing we look at is our isosceles triangle. So I'm going to highlight the isosceles triangle in the yellow. Everybody see the isosceles triangle? So what I mean, that means that this angle here and this angle here are equal. Do you agree? Excellent. I see somebody said they see the twin angles. I see the twin angles too. Anybody see the twin angles? And I see the internal and external angles as well. Look at you guys. Look at you guys. Let me make sure I highlight them so everybody else could see. Look at the twin angles here. This is one of the twin angles. And look at another twin angles here. Everybody seen it now? So this and this would be equal. Talk to me. Talk to me. Then anybody seen the internal and external angle? Once you see an angle out here, you know it's the external angle. What is 63 equal to? Which one of them they equal to? Let me see who thinking. And why? Because this is where, is it why? I want to know. You tell me. I said that just to fool. It's not why. It's somebody else. It's who? Remember, it's on the opposite side. So if the external angle is on the left, that means it is equal to the internal on the right. So that means here is 63. So I would put 63 here one time so I know. I put back my 90-degree angle. Anybody realize we don't find any answers? Any other theorems? Anybody seen the right angle and the tangent? What is the angle between the right angle and the tangent? What angle that's supposed to be? 90 degrees. And if one side is 90, the other side is 90. That ain't mean I could find this angle in between here. Who could tell me what this green angle gonna be then? If these two add up to 90 degrees, isn't it easy for me to find this angle inside here? Hello? How do I find this angle here? And say 90 minus 63. I feel like people not talking. Everybody see how I got that? So far, I don't know what this here is. This is 63 as well, because these are the twin angles. We don't talk about it. Watch another thing now. Let me erase all of this. If this is 63, we know somebody else who is 63. If this is in the isosceles, Think about it. If here is 63, that means inside here ain't 63. Do you agree? So that I mean I could find this angle here. All angles in a triangle add up to what? So that means how would I find this third one? 180 minus 63 plus 63. If you got it, say got it. You realize we ain't even watched none of the questions that they ask us for? Anybody realize that? Because we just make sure that we understand the image all the way through. You do not start looking at the questions until you understand the diagram fully. Now that we think we understand the diagram fully, let's go back now and look at the questions that they asked for. So the first one, explain why X and angle NQL are equal. You remember I told you they stop asking you to calculate things now? What they keep asking you for now? They're asking you for explanations. So let's look at it. Angle X and NQL. X and NQL. What is the reason for this? They're saying twin angles. So you can literally write, do not write twin angles because that's not a rule, but I just put in it here because we know it as twin angles. But what's the rules for twin angles? Angles in the same segment. Excellent, Gav. Are equal. If you got it, say got it. Quickly. Everybody see? Angles in the same segment are equal. All right, let's look. The angles, blah, blah. Determine the value of each of the following angles, angles X. But that ain't easy. So X is just what? 63. Remember this? Everybody with me? Everybody, you see that? The angles opposite each other that we did before too? You realize we didn't even have to think about it because we knew this from before. So 63 and then Y. How did we find Y? Then the same thing we spoke about. If here is 63, here is 63, and all angles in a triangle add up to 180. So guess what? We done. How was that? Talk to me quickly, guys. How was that? How was that? How was that? And you see how fast, you see the difference between looking at a question and trying to read the question first. You don't ever do that. You dissect the question, you dissect the image as much as possible. Now, let's move on to the dark side. Bearings. Now, what are some of the things you realize? They gave us our what? Our knot line, right? See, that's why Sunday classes are so important, right? Sunday classes are extremely important for that exact reason. So let's read through this, guys, together. And listen, I want you to start putting yourself like you're in the exam. Stop waiting on me to explain something to see if you know what to do. Everybody see what I'm saying? So when you read the question, when I read the question together, see if the things that I say align with the way you're thinking. Because they're going to tell you if you're studying the right way or you're not paying attention to the right thing so you could improve, right? So it says two ports, E and G. So make sure you know these are the two important things they're talking about first, are on ground level, 245 kilometers apart. Make sure that information is here. So 245 is here. The bearing of E from G, so from, remember we spoke about our from position? That's why the knot line is here. The knot line is always at the from position. Because at doing this, because sometimes they don't tell you what the knot line is, you got to put in the knot line. On a bearing of 228 degrees. Is that information in this picture? No. So how do I add this information, guys? Anybody have an idea where to put this? A bearing of 302. If you know how to draw, where to draw this 302, say yes. If you're not sure, say no. The bearing is from E of E from G, and it's 302. Look at G and look at E, and remember what direction I teach you how to draw bearings. Where the bearings direction, is it clockwise or anti-clockwise? And it always starts from where? In the north line. So let's go together. So that means from here, this is where you start counting or measuring your degrees. So this is 0. You come wrong past 90. You come across. Where should I stop? Should I stop here? Quick, talk to me. Should I stop here? No, because here's the bearing to F. They said bearing to F. They said the bearing to what? To E. So that means we gotta go all the way here. So that means this angle is what? 302 degrees. I need to stop mark up on my my board, please. Let's pause right here. Everybody with me so far? And you realize this information is not on your graph. You have to put it in. Talk to me, my loves. Let's go, let's go. We're cooking on gas. We're getting something out of this question. Are you with me? Yes or no? So you understand how we got this 302. Let's read the next part now. A ship is anchored at F, some distance away from G. So I like to look at my picture to make sure I see what they're talking about. So F is a distance away from G. On a bearing of, and you realize it's from G again, on a bearing of 228. So let's use a different color. This is our next bearing now. And how much is that? 228. So let me go. So we start from the north line again. But where are we going to stop? We're going to stop here. I already thinking something. Anybody already seen something? Anybody realize we could calculate that angle inside the triangle? Anybody seen what I seen before we do anything else? Is anybody seeing what I think I want you to see? Look inside that triangle here. Look at where green stop and look at where red stop. Isn't it possible for us to find a missing angle inside there by subtracting? Excellent. Do you agree? Because if all the way up here is 300 and something, and then from here to here is 280, here would be the difference of the two. Did they even ask us to find that yet? We don't know. But I like to find these things without people telling me to. So somebody calculate that for me there, please. So that means EGF. I can just write it. You take a pencil and you write it to the side. EGF is 302 minus 228. And that's 80. You sure? Somebody confirm 74. And you know, I love the fact that you are using the 3 digits. Is the bearings. But the angle inside, you realize that's different now, eh? Because this is the angle, you could use 2 digits. If you're doing the bearings, it has to be 3. Yeah? So the angle itself would be 74 degrees. And guess what I'm going to do now? I'm going to put 74 in here with my pencil. May read the question yet in a day. May know what they want us to find, but I know I got 2 angles in my triangle. That ain't mean we could find this one now. Let me see who thinking outside the box. Anybody realize what I'm teaching you? I'm teaching you how to make connections. How do I find this missing angle here? They ain't ask me nothing about it, eh? But I want to know if you know. How do I find this angle here that I just label X? Add both angles and then what? Subtract from 180. Exactly. Everybody realize that because all 3 angles in a triangle add up to 180 degrees. You see how all the information coming together? So me will just literally go here and work this out. Quick, 180. Even if I just put the work in, so when I'm doing my question, I remember what to do, would be 52 plus 74. All right, look at that. Boom. So let's see if we know. And the last question, just in case. Who would know how to find this angle between here? Who would know what to do to find the yellow part? Suppose they ask us to find the yellow part. Who would know how much to calculate that for? How much is that? If it was a full circle, how much degrees is a full circle? So that means what would I do with the 360? What would I subtract from the 360? And the 302? And the red, subtract the red from it, the 302. Okay, I just want to see these things. Yeah, that's all I want. Okay, let's read the questions now, guys. Let's see if we could handle what they ask us to find. On the diagram, insert the angle 228 from the bearings. We ain't done do that already. Everybody see that's one mark there. Easy so. Hello? Guys? If you got it, say got it. I'm watching the chat. Let's go. You see, bearings is not hard. Bearings is actually so easy if you understand how to read the question and use the rules, yeah? All right. Determine the value of angle FEG. FEG. Now watch this here now. We ain't done find FEG. In trigonometry, we call questions either direct or indirect. What would have been a direct question? A direct question is where you don't have to do the calculations because you could use a rule and find out the missing angle. Indirect means you have to find an angle first before you could find the angle they ask you for. In this case, what they're asking us for, FEG. Where's FEG? FEG. That means that's the angle here. How did we find this angle here? We didn't have to find this one first. We didn't have to find this first, add it, and then subtract from 180, which is what we did here. Oh, Lord. Everybody see what I'm talking about? Then the angle we found here. Could we have found this without 74? We would have never find X without 74. Do you agree? So do you see the importance of sometimes using the information that you could find to find the information they would eventually ask you for? So we know that's the answer. So you see, look at it here. Everybody see what we did there? You realize we didn't have to think all about this in the one moment because we already did the work before we even start the question. I want to pause right here and make sure everybody see what I'm trying to teach you. Everybody understand what I'm trying to teach you to do? When you be proactive with these questions, when the question comes up, it's a lot easier to answer because you did most of the work at the beginning. So you don't see all the rules, you don't see all of the different types of questions. So you kind of have a map so that when you read a question, you know which direction to go, left, right, up, or down. All right. I hope everybody with me. All right, so let's move on. So basically, this is exactly, look at this. This is exactly what we just did. Because this was just us putting the information from the paragraph in the picture, you know, that's all it did. And after we put the information, we were able to use what we know to find missing angles. So when they ask us the questions, it's easy for us to put one and one together. All right, so that's it. That's exactly what you do. You find 74 first by subtracting these two. And then you know angles in a triangle add up to 180. So you add up these two and you subtract from 180. There you go. You get your answer 54. Now let's look at the next one. Calculate the distance the ship is from port G. Now, what's going on here now? What distance they ask for? They ask to find GF. Where's GF? GF. No, anybody could tell me. So let's call this X. Anybody know which rule to use? The sine rule or the cosine rule? We know it's nothing with the right angle because this is a non-right angle triangle. Which one would you use? Obviously, it's the sine rule. Let me tell you why it's the sine rule. Because we got two angles on one side. I want to show you something. Hold on here. Didn't I do trigonometry with us on a Sunday before? Anybody remember? I think I did, you know. Class, anybody remember if we did trigonometry? Yes, we did. So I need her to take a picture of this again because we did this. Yup, look at here. Look at here. These are the notes here, and this is what we practice. When to use the sine rule and when to use the cosine rule. Hold on. Take a picture of this. You use the sine rule if you got two angles and one side, or if you got two sides and an angle that is not between. When you finish, take a picture of this, say done. You see this? You got to copy this down and memorize this. This is important. When my students have my summary book, so they would have this already. Just check your notes and make sure it's like this. For everybody else who don't have a summary sheet yet, you could take a picture of this. And then for the cosine rule, hold on. What are the two conditions? What are the two conditions here? The two conditions is either if you have three sides or two sides with the angles in between. So that's the two conditions. So take a picture of that. So moving forward, we should all know when to use the sine rule and the cosine rule. So the sine rule is not between, or you got two angles on one side. The cosine rule is the angle is between or all three sides. Yeah? So now that we have that clear, we could start getting down into the actual question. And then we could answer and move forward. All right, so let's go. So based on this, what do we have? We have two angles and a missing side. Now, how do I answer a sine rule? Should I work it out from scratch as the first example, everybody? You think I should do it? Work it out from scratch? Let's do the 4 steps. What's the 4 steps? The first step is formula, right? So A over sine A is equal to B over sine B. How do you know how to substitute here? But before I start, I want to check to see who are paying attention and who are watching and who are not, who just sign on and not here. So if you're here, just say ready. Let me see something. All right. Thank you very much, guys. All right, so let's go. So step 1 is always formula. Step 2 is substitution. Now, if you realize here, we have a side and the angle opposite, a side and the angle opposite. So obviously, we got to match up. You use the pair that you have in the picture. So do we have a pair, a side, and a matching angle that's opposite each other? Anybody? Do we have that? Do we have a matching pair? What numbers would be the matching pair? And 245 and the opposite angle, which is 52. That end with first matching pair. Do you agree? So there we go. What is go on the top? The angle gonna go on the top. So you put the 245 over sine the angle, which is sine 52. Everybody with me so far? Equal. Now, the one that missing is what you're looking for, right or wrong? So what would be the next two matching sides, everybody? In this case, what would it be? X. Let me use a different color. It would be X and what angle? So we put X up here. Excellent job. Excellent job. Excellent job, guys. Excellent. So we're going to put X over 54. Now, if you don't know how to work this out, let's work it out together. Sin 52 ain't a number. So that's the first thing you need to find out. What is sin 52? So we're going to do the working now. Calculators, everybody. 245 divided by what? What is sin 52? To 3DPs, 0.788 equal to X over 54. Now, once you reach here, right, guys, once you reach here, what would you do next? What operation would you do next? These ain't two numbers. So that means what do you do next? You and divide these two numbers. So let's go. 245 divided by this. Tell me what answer again. 310. Somebody to back that up, 310, you always use a decimal point. 0.91 is equal to x over 54. Everybody in this example, what we doing? We switching or we multiplying? This is a very important question. I need everybody to let me know. Are we switching or are we multiplying? So that means I want, if anything sticking. How do we know if to switch A and based on where the location of the X is? Look at where the X is. Do I need to switch? When do I switch? Don't we switch when X is in the denominator? Where is X right now? X ain't where we want it. Once it's on the top, we multiply, right or wrong? Because we need to just get rid of everybody else. This is divided by 54, so we get rid of divided by 54 by multiplying. If X was in the denominator, that's when you switch. So let me make that clear. That's why I asked. You switch when X is in the denominator. Everybody with me? So if you're multiplying in this case, this would cancel this. Whatever you do on one side, you do on the other side. So X is equal to 310.91 times 54. Somebody work that out for me there, please. We're going to calculate. Nobody, only 2 people in the class got a calculator. Anybody realize? Nobody, and watch the attention to detail. There's something that's missing. Let me see. Nobody ain't watching nothing here. I literally do this just to see if anybody sees something. Anybody see what's supposed to be going on? Me ain't care about the answer. Ain't the answer I care about. I asking what a part of the working that's missing. Something missing. Something students do all the time. Nope. Go back up. Go through this here and let's see if who could pay attention to the details. There's an error on the board. Something was forgotten. I need to see if anybody could find it. Not the units. Sin what? Is sin missing, but sin what? Sin B. So instead of what, where should sin B go? Next to what number? Everybody seen it now? Not the 245, the 54. Look at it. A is 245, sin A, sin 52. B is X, and the bottom should say sin 54. So let me go. This shouldn't be just 54. This should be what? Sin 54. So what is sin 54? And we should find it out the same time when we did it here. Sin 54 is what? That's what you have, Gav? That's it there? What's sin 54? 0.8090. So instead of multiplying by 54, we should have multiplied by 0.8090. 0.8090 on both sides. And then that would give us our final answer, which is, because this and this is going to cancel. So X is equal to 310.91 times 0.809. And how much is that? $251.53. 53 or 52? What number came after the 2? Exactly. So if it's a 5-2 and a 6 comes after, it would become 5-3. Yeah? And then you put your kilometers. Now, tell me the truth. Was anything about this difficult? That question specifically? what you realize you had to do? You had to do what? You had to look at the picture. And just like how I trained you guys, I could say train, yes. Because all you had to do is one, you know that this is not a right angle. So it's only two rules you could use for this, right? What's the two rules? It's either the sine rule or the cosine rule. Based on what information you have, which was we had two angles and a side. So the only time we could use two angles and a side is the sine rule. So after we did that, we followed the four steps. What's the four steps? Formula, substitution, and then you're working, and then you answer. All right? So let's move. Let's read the next question. Indicate the point H on the line EF such that GH is the shortest distance from G to EF. No, I'm glad we're doing this because honestly, this is not on the CXC syllabus. This was the first time a question like this ever came. So may know if this is something they expect students to know overall, but we're gonna learn this now. So, because this is the first time a question like this ever came on any question ever. So everybody here with me and locked in? Because this is something I need you to write. If ever they ever ask you, right, to find the shortest distance between 2 points, that information, that line is a perpendicular line. That means that line is a 90-degree line between the two spaces. So everybody write that. The perpendicular distance is the shortest. So the shortest distance from G to EF is a perpendicular distance. Please write this down. My students, write it down in our summary notebook. Everybody else, write it down in your notebooks. Everybody with me? If you're done, say done so I could know to continue. Now, check this out. This A mean now we got a right angle triangle if this is the perpendicular distance. So even before I look through, that ain't mean we're now dealing with a right angle triangle. What topic do you think we need to use to find GH? It's only two options again. It's either Pythagoras or Triggs. Which one you think we need to use? Think about the conditions between the two. Remember Pythagoras, how much sides you must have? You must have two out of the three. In this example, we only got one. So what does that mean, everybody? What are we left to use? Now, how do we know we can use Triggs? Wayne have a side and Wayne have an angle. Right or wrong? So that means that this line here, what should I label this line? That the line we want to know. What should I label that line? Let me see who's thinking. What do we label unknown things that we want to find? Very good. X. Then we have a side. What should I call this side? What is this side? What is the label for this side here? What is the 245 name? What's up? God, what's up? Hype. Excellent. Everybody agree? This ain't the hypotenuse. So that means what is X then? What side is X? What do we label X? Let me see who really watch the angle. Watch the angle. Watch the angle in X. Because we can't use 74. 74 get chopped up. The only angle we could use is 54. Everybody seen it? So what trig ratio uses up and height? That's sin. The sin theta is equal to what? Up over height. So we follow the four steps. Up is what? X. So everybody, let me pause right here. Everybody understand what we just did just now? You realize within this triangle, we make a right angle triangle. So that means the only rules we could have used is Pythagoras and Triggs. And everybody know why we can't use Pythagoras. We don't have two sides. We only have one and an angle, which means that we can use what? Triggs. If you got it, say got it. All right, so let's do the working. So it's going to be sin 1, sin 54. Some people get calculators is equal to up, which is x over height, which is 245. So what is sin 54, somebody? And it's 0.8090. You sure it's 89 or 809? Is equal to x over 245. Everybody multiply or switch. Let me see if we learning anything. Everybody, and I'm not moving on until I see majority of people answer. Multiply or switch. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But that's what we're talking about, you know, guys. That's what we're talking about. Period. So we multiply very good by 245. Whatever we do on one side, we do on the other side, right? So that's going to cancel. So x is equal to 0.8090 times 245 calculators. What does that give us? One 98.2. 198.2. Excellent job. Very good, guys. They made a mistake here. They were supposed to use 245. 245. They use a wrong number by mistake. GH. Yeah. Kilometers. We finished with first exam. Feedback. How you feeling? How you thinking? How was it? Was it that bad? Do you start to like understand how you're supposed to be looking at bearings? Don't stress about bearings. It all comes down to the triangle. Anybody realize that? Once you use the rules and you come down, it comes down to your triangle. And once you know your triangle and you know your rules, you just choose the one that is appropriate. Let's go. Talk to me. Talk to me. I seen people responding. Because this was January, and January is always an easy exam. Okay, so should we, what time it is? We got enough time to do one more at least. Should we do one more? So I'm going to move through a little faster because I think that everybody kind of understand the drift. You see how paper question 9 comes? You should start to like have an idea how we move. And I shouldn't have to teach or explain things as much because you now have the general scope of everything going to be required of you to answer. So let's move to last year, June. So this is June 2024. And again, if you want to go through more examples on your own, I send everybody the website, the past paper website with the answers to our past papers. You could do this on your own, right? Okay. So let's run through this here quickly. Should I do this or should I focus more on the bearings question? What y'all want me to do? Do the whole thing? Should we do the whole thing? Just to kind of even get you more comfortable with circle theorems, everything? Okay. Celeste. Celeste, you know, I got y'all back. Period. So, what did Miss V teach you? Miss V teach you to find as much angles as you can without looking at the questions. So, I done seen something. So, let's go through this together. Anybody seen the twin angles? I seen twin angles. Right or wrong? So, if here is 62, what I mean, here is 62. Just so. Anybody seen angles at the center and angles at the circumference? Who is the angle at the center? C, right or wrong? So that means there's going to be twice a day. So how much is this? Come, let's calculate it one time. We put it in the picture, we know it. 124. Just say that we know two angles. And next thing I know, let me tilt my head to the side. Anybody seen the diameter? Anybody seen the 90-degree in the diameter? The semicircle, look on your left-hand side. Tilt your head to the left. Tell me if you've seen it. This is the diameter here. That ain't mean all three of these here add up to what? 90. Tell me if you've seen it. No, anybody seen the internal and the external opposite? I seen the isotriangle too, a period. Hey! Okay, which one to talk about first? Let's talk about the external and the internal first. Anybody seen the external and the internal? So that means if here is 62, that means here is what? 62. Yeah? Good. Anybody seen the isotriangle? Very good, very good. I see the isotriangle. Actually, I see two isotriangles. Tell me if you see the two isotriangles. One facing down and one facing right. Tell me if you've seen the two of them. So I'm going to highlight them just to see. This is one here. Everybody see that one? And then there's a next one here. All right, seen it? Now watch this now. This ain't a straight line. I cheat in the code, eh? This ain't a straight line. So we know these two gonna add up to 180. I'm just trying to show you that you could find anything you want. That's the point of this, right? You could find this missing one by subtracting this from 180. Do you agree? Okay, let's do something else here. How would you find this angle in between here? That ain't easy. Because this is an isotriangle, you can find it two ways. What's the two ways you can find this? The two ways is that this is 90 degrees. Do you agree? The angle between a radius and a tangent. You see the tangent? So you subtract the 62, this would give you that. If you know this angle, that mean that's the same answer for here. Everybody seen it? What is another way to find these angles? All three of them add up to 180. Because it's twin angles, you would say 180, you take away the 124, and then wherever left back, you divide by 2. Because wherever left back, I get split between these two angles equally. Hello? Are you with me? No, watch this now. How do I find both of these two together? For me to find E, watch this. All three angles in a triangle don't add up to 180. So look at this. If you find this whole angle, which you can, because you know this piece and you know this piece, you add it up to give you this whole piece here. Look at this triangle here. All three angles ain't gonna add up to 180. So if you take this, you add up this, and you say 180 minus that, it's gonna leave you back. And we know this one. So wherever, let's say this was 70 and this was 25. How do we find this small piece? And subtract the 25 from the 70. So let's stop here. How was that? Everybody feeling good about how we just broke down this entire question? So we ready to answer? So let's go. First question. State the theorem. Oh, I realize again, they tell us the answer and they ask you to state the reasons. State a theorem that justifies the value of each of the following angles. What I mean, you have to memorize the theorems. You can know to find it, but you got to memorize the theorems. They say angle B is 62. What is the rule with that one? Angles in the same one. They're in the same thing like the last exam. Angles in the same segment are equal. Okay? Hello? If you got it, say got it. We said this already. Come on, guys. Let's go, let's go, let's go. Let's go out with a bang. Everybody engage, hands on board. Let's go to the next one. B, C is 124. We know that. Look at it. Why is C? You see, they tell you C is 124. We knew that. We been knew that. But why? What rule is this one? Angles at the center is twice angles at the circumference. So you remember I told y'all this? They stop telling you find the answer. They're asking you the reason. They're asking you to give the rules. Please learn your rules. All right, 124. So 2 times 62 angles at the center, twice angles at the circumference. Bang. Next one, OVW is 90. Where's that? OVW. OVW. What rule is that one? The angle between what? A tangent and a radius is 90 degrees. But this exam easy. And you know why so much people fail? Why people fail? Anybody could tell me why people fail this exam? They don't know the rules. They don't know the laws. They don't know the theorems. You know how frustrating it is that you wouldn't know, yeah, it's 90 degrees, but you can't say why? Please to learn your rules. All right, let's keep it moving. The next one say, find the angles A, D, and E. Show all workings where appropriate. So let's go. Where was A? Where was A? Oh, A was outside. We found A because the internal is equal to the external opposite, right? Everybody remember that one? We found that one already as well. Look at the same thing here. Didn't we find this as well? We know that this is 90 degrees. Same thing we said before. So if here's 62, this would be 90 minus 62, which is equal to 28. And once we know here is 28, we know here is 28. That's one way. Or what was the second way? 180 minus 124. And you take your answer and you divide by 2. If you got it, say got it. Sometimes they just ask you for both. Sometimes they just say state the 2 ways you could find the answer. That is why I'm making sure I explain the different ways. Yeah. And what was the next? They're saying the same thing I explained from before too. How to find 44. All angles in a triangle add up to 180. So you know these two, you add them up. And you know this one. So if you say 180 minus the 62 plus whatever this gives us, what is going to give us? 1646. Yeah. And then you know whatever that's going to give us. Somebody calculate it, please. 180 minus this, which would be 108. So this would end up giving me 72. So if both here add up to 72, how do you find 44? You subtract this part. So it's a 72 minus 28. Because remember, we had this one before. So you subtract it back and give you your 44. Yeah? And guess what? That's it. Rate yourself out of 10 on this one here. If you think you would have been able, based on your understanding, out of 10, let's go. 10 if you understood everything that we just do just now. 5 if you only understood half. 7 and 8 is in between there. 0 is if you understood nothing at all. I'm watching. So ladies and gentlemen, what is your number one priority in studying on your own? What is your number one priority? If you don't prepare adequately, the exam will rip you up. Listen to me. Prepare by learning your rules. Memorize them like the back of your hand. Go in the exam feeling confident because you know what you're supposed to know. Because when the questions come, it doesn't matter how it comes, you should be able to dissect it because you know what you're supposed to know. It's students who don't go in knowing what they're supposed to know, who struggle because when they read, they don't know how to make the connections. How you make connections of something you don't know and have in your head. You got to understand the rules. Yeah? So I hope everybody promise me, because if you don't do that, that means you're wasting your time even being in class, because that means you ain't learning nothing that you're supposed to really do. Okay? All right. So let's move into the second half of the question, which is another bearings question. Let's see how often bearings has come. I just want to see something for the past couple of years. So this was June 2024. So you see, January 2024 was the same thing. Circle theorems, bearings. Next one again. This was what, January 2023. Circle theorem, same thing, bearings. Hold on. Oh, look, we lost them here. It is here. Let's look at this one. This one was circle theorems, bearings again. So if you're really going that exam, not just practicing a lot of bearings and circle theorems, you really want some slap. I mean, how else to say it, to be honest. Like you don't know how the question gonna come. And even if you ain't realize you're seeing no angles of elevation and depression, that's a sign to still make sure you're good in it. Everybody listening? Even though the pattern is that you realize we ain't see not one angle of elevation or depression. That is why I kind of start off the class with it. We don't ever go off of what they do and what they don't do. We prepare for everything. Everybody with me? Hello? So if an angle of elevation and depression question come and I read the paper, I should be thinking to myself, yeah, that's my students gonna be all right because they know what to do, regardless. All right, so let's finish up this last part of the question. Before I leave my class tomorrow, those who I have on Monday and Tuesday, which should be everybody. This is what we're gonna be doing tomorrow. Past paper drilling time. Please make sure you know your formulas and your everything we did tonight. We're going to just be drilling on the time constraints. So before you go to sleep, just do a quick revision for class tomorrow. All right, there we go. The diagram below shows a quadrilateral formed by joining two triangles. So let's make sure we see the two triangles. So in the triangles, we see some things. I didn't watch what's going on. So this triangle got two sides and one angle, and the angle is between or not between? Talk to me. The top angle, SRQ, is this angle between or not between? Excellent. So which rule would you use to find the third side for this one? Excellent. The cosine rule. Be careful, eh? If you say cos, that's tricks. So you have to list out this one. It's a cosine rule. Okay, that's different. Excellent job, everybody. Look at this one now. This triangle here. We have in this case two angles and one side. What rule is this one? What is the rule when you got two angles and one side? The sine rule. Excellent job. Oh my God, I could cry. I could cry, guys. I'm so proud of you. So you realize we ain't read no questions yet, but we have an idea of what constraints we have. We have an idea of what type of information we are given. Yeah? Very good. Excellent. In addition to knowing that all angles in a triangle add up to 180, doesn't that mean I could find this angle here? You realize we ain't read no questions, so we ain't know what they want from us, but we still preparing ourselves. Ladies and gentlemen, can I calculate angle P? Angle P is in this triangle, and in the triangle, we got two angles out of the three. So what would I do? I would add up 72 and 43 and subtract it from. So listen, we prepare. So I would have take my pencil and I would have just do this quick on the side. We would have just add this there. May know if I'm gonna need it or not, but in case I do, I have it already. Boom. So I don't know this triangle gonna need the sine rule. This triangle, if I do come to it, I know I need to use the cosine rule. I know how to find this angle here. If I know this angle, may I know this angle too. Because if we look at the bigger picture, no, we don't. We can't use that, no. Because you would need all three angles of the quadrilateral, and we don't have all three. Because technically, we don't have this whole angle here. Because we have this whole angle here. We got this whole, everybody see what I'm saying? So for me to find this angle here, using the quadrilateral rule, I would have needed to have this whole thing, which we don't. So we would have to use another approach, which is fine, which is possible. All right, so now that we kind of dissect the picture, let's look at the question. Calculate the length of QR. That's so easy. We know it's the cosine rule. We ain't doing no cosine rule practice, so let's go. Take a deep breath because the cosine rule is very, very tedious. Like, yeah, very, very tedious. So this is angle A, and this would be side A. Do you agree? So let's get the formula. A square is equal to B square plus C square minus BC cos A. So everybody, it doesn't matter who is the B and C, to be honest, once you just pay attention to the details. So there we go. Calculate us out. So let's say 16 square plus 18 square. We substitute, and that's how we're doing it. Number BC, cos A is all multiplication. What is B? B is 16 times 18 times cos 25. Now, let me ask you a question. Cos 25 ain't just a regular number, ain't a decimal number. And this is A square. You pull back A square. So let me pause right here. And everybody confirm with me if you okay. Are you good so far? Hey, who that be? Who just said that? There's a reason why I said that, you know. Who to who who said that? Who realized the trap? Somebody see the trap. Let me say, anybody else see the trap? Maybe they see it as well. Something missing. Is this good? Are we good? Everybody agree? Or no, are you not sure? Ladies and gentlemen, talk to me. You got to at least be familiar with the formulas, guys. There's a reason why it's important to pay attention to every small detail, okay? Because sometimes even CXC make mistakes. So you got to be mindful of where you should be writing, where you should be writing. So a two should be here and a two should be there. That's why I ask everybody if you're good to see who really locked in. Now that we have everything, let's go calculators. So A square, let's go. I need people to be typing these figures quickly. 16 square, 256 plus 18 square, 324 minus 2 times 16 times 18. You could put that in your calculator one time. What is that? 576. What is cos? What is cos 25? What is cos 25? That should be a decimal. 0.906. Now watch here. This is the challenge. Everybody write this down and tell me what you get for A. I'm gonna be honest with you. If you could finish this, you're in a strong position. If you are unable to finish this, that gonna tell me, or that should tell you what you got to do when it comes to practicing, because the rest of this is algebra. So everybody, work this out for me, please, and tell me. All I need you to post is what A is. I'm gonna work out the answer after. You could send it to me directly if you don't want to send it to the class, that's okay. But I'm also paying attention. All right, just a general notice as well. A few persons asked me to purchase my book. I may be able to get 4 or 5 copies for this week, but you would have to let me know tonight, confirm tonight. So if you are interested in the summary book, or to at least see it, you can let me know, and I will try to work out something. I can't promise that I'll be able to get everybody one, but I will try my best. Okay. So we're getting some numbers. So one person says 7.61. Another person says 7.62. Okay. Anybody else? Let's go. If you're stuck, let me know if you're stuck as well, because that's important to know. Anybody else? Should I work it out now? Should I wait? It's stuck? That's no problem. Anybody else? Talk to me so I can know what to do, please. Communication. All right, so let's go through it together, guys. Let's go through. Let's go through. Let's go through. Don't forget to square root at the end, Gav. Did you square root? Did you square root that? 'Cause remember, it's a square, the answer gonna give you. So you got to square root the number. All right, let's go. Not Gav, Gino. So let's go, everybody. So here, when you look at this, what bad maths tell you must do? You could do two things at once without affecting the other thing. First thing, you multiply these two things by each other. So you put a square is equal to, you add these two. So what do we get when we add these to somebody? 256 plus 324. That should be 749. Is that true? Back check, please. 749. How do I get that? Carry over. 256. I don't know where I had 3. 8, 24. 580. Yeah. Thank you. 580 minus, and then when we multiply these two, what we get? 576. 5 times 0.906. What we get? 520, 522.03. Because you know, bad math, you could add these two and then subtract your answer from here. So a square, when we subtract, what do we get? 580 minus 522.03. 57? Somebody? 57.97. And what do we do next? We square root both sides. So square root the answer. So A is equal to 7.61. Hello? Everybody see that? We did it. If it got it, say got it no. Everybody, so simple that is really, once you substitute, is the working part, you got to work out, right? And everybody know what is the cosine law. All right, so let's move on to the next question. The next question now, Jesus. Yeah, the next question now asks for the bearing of P from S. So let's not use that picture. It said the bearing of P from S is 205. Determine the bearing of R to S. So let's look here. The bearing of P from S, where's S? So no, because it says from S, where do I draw my knot line, everybody? I want to do this from scratch so that we see. Everybody agree? So from S. And what is the bearing that they ask us for? They gave us the bearing from R to bearing from P. Where is P? 205. So how do we draw a circle thingy? So let's erase this. So all of this is 205. Okay, so everybody agree? The whole thing is 205. And they want R from S. That ain't easy. Who could tell me what to do? That's so easy. The answer right there on the board. What do we do? What's the main operations? Because there's two operations we gotta do. They want the bearing from of R to S. So they want from here to here. Let's make sure everybody agree that that's what they want. They want no problem, no problem. Vanny says that everybody add then subtract. Everybody agree? All three of these angles make up 205. If from here to here is these two, to find the extra, you add these two and you subtract, right? Pretty straightforward. Excellent job, everybody. That's similar to what we did. You see? Same thing. So you get 108. You added 72 plus the 25, and then you subtract from the 205, you get 108. So from here to here is 108. Hence, the bearing of R from S is 108. S from P. S from P. What I mean, that I mean this is a whole new bearing. So it's from P, that means that I have to do what? Draw a knot line from P. Let's make sure everybody agree. Everybody with me? So you draw your knot line here. So what do they want? The bearing from P to S. So that means what angle they want, everybody? That means they want this angle in here. No, I think I went through this the last time we did this. Anybody remember the rule? Let me see if I could turn this. Anybody seen the internal angles? Okay, let me draw this and show y'all something. All right, watching? Don't give up yet. We almost there. Okay, first thing first, everybody seen the Z? What do we know about the Z? We know that, this is what we know about the Z, that we know here and here are going to be equal, right or wrong? So if this is A, this is A. Agreed? What you should also know too is that if they're on the same side, if this is A and this is B, you should know that A and B add up to 180. This is called interior angles. Everybody should know interior angles, right? Watch this now. Where did it go? I just gotta find it. Hold on. Okay, look at here. Watch this now, guys. I'm gonna turn this like this. Anybody seeing the similarities now? Hold on. Let me move it up. It just it gone the other way. It slant the other way. Anybody see what I'm trying to show you? Anybody seeing the internal angles? So let me use yellow to show you what I mean. This angle here and this angle here would add up to 180 because the north line and the north line in two parallel lines like this. This is something you need to know. Everybody see that? But the question is, which one of these ones we could find? Don't we know how to find this? All of this ain't 360. So how do I find S? This angle here by S. We subtract what numbers? 360 minus A in the whole 205. Tell me if you agree with me. And once you find the angle, what would be that angle there now, guys? 360 minus 205 is what? 155? Somebody back check, please. 155. So if here's 155, that means here is what? 180 minus 155. Because both of them add up to 180. So what is that? 25 degrees. So let's back check and see. Yep. Everybody see? May not understand why they had to go through all this. This seemed way more difficult than this one. Which one do y'all prefer? Because this is like it's the same concept they're trying to explain, but it's more difficult. I don't know why they going through all that. You do it the way you understand it once you know the rules, yeah? All right, so babes, everybody, that's it for, yeah, it's just to remember the rules. So how was this exam? This was an exam a lot of people, this failed. This was last June. How was this one? You see how fast we were able to go through it? So this is your final score on how you feel about this topic now. We only got to do 2 exams today, but if you notice, a lot of the exams is the same concepts coming back, right? Especially with the bearings. So if you was to rank where you are at in question number 9, this is your last score. So in terms of how you think you'll be able to perform in question 9 at this moment, drop your rank. Those who are low, I hope you're also paying attention to what parts you think you're struggling with and what areas you need to work on. Correct. Because you seem to have the basic fundamental understanding. I think you just need to do a lot of practice. Okay? All right, ladies and gentlemen, that's it for this evening. I'm going to download the video and upload it by tomorrow morning and share it with you guys. Don't forget to do your practice, do your practice, do your practice. All right, but that's it. Thank you guys. See you next week, Sunday.